Now that we have created that unit circle resource, let's take a look on how to use it for both angles and for trig functions. Now, the angles that are on your unit circle are all put into standard position. Standard position puts the initial side on the positive x-axis, and the terminal side is always measured counterclockwise. Again, we talk about the first, second, third, and fourth quadrants to kind of identify where things are at. So if I were to draw something that is a 36-degree angle, it would have to start on the x-axis, and then it would be, somewhere up here in the first quadrant, roughly in that position. 315 degrees, still going to start, and then 315 degrees is down here somewhere. If they do happen to go negative with an angle, still put it on the positive x-axis, and now negative 150 would land down here somewhere. Now, if we want to talk about coterminal angles, which you will run into time and time again, coterminal means exactly that. They have the same terminal side. So you already have one on your unit circle. If you look at 0 degrees and 360 degrees, the terminal angle is the same there. Don't confuse this for being the same angle. They look the same, they act the same, but they're not the same angle. Okay? 135 degrees would be the same as going backwards 225 degrees. They would land in the exact same point. They would have the same cosine and sine values. They're not the same angle. And then we could really get crazy if you go 30 degrees, or if you go backwards 330 degrees. If you go all the way around plus another 30, that would be 390 degrees. If you go all the way around twice, and then another 30 degrees, you'd be at 750. Now, if these big angles that aren't on your unit circle, or these small angles that aren't on your unit circle give you issues, we can easily adjust them. If you take something that's too small and add one full rotation, you'll get to a coterminal angle. If you have something that's too big and subtract a full rotation, you'll get back to a coterminal angle. And if it's really big, if I subtract 360 and I subtract 360 again, I get back to that angle. So that's how these are related. That's how those are related. So something that's too big, subtract 360. Something that's too small, add 360. You'll get a coterminal angle. Now, sometimes we talk about angles that aren't necessarily on the unit circle, but they act like things on the unit circle. So on your unit circle, go find an angle down here in the fourth quadrant where these two are the same, but one's positive and one's negative. Okay? You're going to find that angle is laying at about 315 degrees. Now, your unit circle has square root of 2 over 2, negative square root of 2 over 2, but the numbers are the same, one positive, one negative. This must be a 315 degree angle because it acts like it. Or this one right here. I'm going backwards, but those numbers kind of correspond to that 270 degrees. I just want it to be a backwards or a negative angle. 270 degrees would be a coterminal angle for that one. And this one right here, those numbers look very familiar. If I go down to the third quadrant on my unit circle and look for those numbers, they're at about 210 degrees. They just don't have the divide by 2 on the bottom that they should have that my unit circle has. Remember, my unit circle is only one unit for a radius. These happen to be a little bit bigger, but they still act like those same angles. Now let's do some trig work. Okay, again, use your unit circle. You have that resource now. So if I go to 90 degrees and I look at the cosine of 90 degrees, you'll see it's 0. Go to 60 degrees. The sine of 60 degrees. If I go to 150 degrees, the sine at 150 degrees is 1/2. Now, if you get something that's too big, subtract 360 if it helps. So I'm really looking for the cosine of 45 degrees, and the cosine of 45 is square root of 2 over 2. If it's too small, add 360. I'm really looking for the sine of 240 degrees, which is negative square root of 3 over 2. Now, the last two in here, you have to have a good understanding of what tangent is. We talked about this with our unit circle. Tangent is sine over cosine. So this is really saying, what's the sine of 45 degrees? What's the cosine of 45 degrees? And then divide them. So I go find 45 degrees on my unit circle. The sine is square root of 2 over 2. The cosine is also square root of 2 over 2. So I have the same thing on the top as I do on the bottom. So I have a 1. There's an interesting one. If you go to negative 90 degrees, which is the same as 270 on your unit circle, and you look at the sine of negative 90 degrees and the cosine of negative 90 degrees, they're both sitting there. The sine is negative 1, but the cosine is 0. I can't have a 0 on the bottom, so the tangent at negative 90 degrees is actually undefined. There is no answer there. Okay, and we'll explore why that is. Just understand if you ever have that 0 on the bottom, it is an undefined value, which you will find time and again with tangent, but you should always get an answer for the sines and for the cosines.